Hello guys, welcome back. Today we will be doing scalar products, orthogonal vectors and orthonormal vectors. Now let's start with the scalar products. Suppose we have a three-dimensional vectors a and b. Then the dot product between a and b is giving us a1 times b1 plus a2 times b2 plus a3 times b3. Simply put, we first have to multiply these entries component wise. Then we add our results. That will give us the dot product between these two vectors. Now we know how to find the dot product. Let's move on to solve some few examples. Example 1, we have to compute the dot product between a and b, where a is giving us 1, 2, 3 and b is giving us 5 minus 3, 4. So now the dot product between a and b will be giving us the I component in a multiplied by the I component in b. That's 1 multiplying 5. Then plus the j component in a multiplied by the j component in b, 2 times minus 3, same for the k component. So now simplifying, this gives 5 minus 6 plus 12. Thus we are going to have 11. So with our next example, we have to compute the dot product between a and b. The dot product between a and b will be giving us 3 times 1 plus minus 2 multiplying. Now note that the j component in b is 0, right? So here will be 0 plus 4 multiplying minus 5. So we are going to have 3 minus 20. That's going to give us minus 17. So that's the dot product between a and b. Two vectors are said to be orthogonal if their dot product is 0, or simply put, two vectors are orthogonal when the angle between these two vectors is 90 degrees. So now let's try some few examples on orthogonal vectors. For example, we have to determine whether the given vectors are orthogonal or not. So the first one, we have these two vectors. So that's, we should just find their dot product. If their dot product is 0, then these two vectors are orthogonal. Now let's compute the dot product between a and b. We are going to have minus 1 multiplying 4 plus 5 multiplying 2 plus 2 multiplying minus 3. That's going to give us minus 4 plus 10 minus 6, which will give us 0. Thus, the vectors a and b are orthogonal. With the second example, so we are given these two vectors and we have to determine that these two vectors are orthogonal. So now let's find their dot products and see if we are going to get 0. Computing the dot product of a and b gives minus 1 multiplying 3 plus 2 multiplying 4 plus 5 multiplying minus 1. So we are going to have minus 3 plus 8 minus 5, which will give us 0. So in this case also we have these two vectors being orthogonal. We now move on to orthonormal sets. A set of vectors is said to be an orthonormal set if these two conditions hold. 1. The vectors should be unit vectors. Thus, each of the vectors should have a magnitude of 1. And the second condition is the vectors should be orthogonal. So let's try our first example on orthonormal sets. So with this question, we have to verify if the following set of vectors is an orthonormal set. So all that we need to do is to show that all those two conditions are met. Now verify if the norm of u1 is equal to 1. Now let's compute the norm of u1. So norm of u1 is giving us the square root of 4 on 6 plus 1 on 6 plus 1 on 6, which should be giving us square root of 6 on 6, and that's equal to 1. So we have u1 to be a unit vector. Now let's verify that of u2 and u3. The norm of u2 will be giving us the square root of 0 plus 1 over 2 plus 1 over 2, which is equal to 1. So that's u2 is also a unit vector. Now what of u3? Norm of u3 to be giving us the square root of 1 over 3 plus 1 over 3 plus 1 over 3, which is going to give us square root of 3 on 3, and that's equal to 1. So here we see that all these vectors are unit vectors. So now the next condition is, are these vectors orthogonal? So now let's verify that of the second condition. So we now move on to verify the second condition. Now the question is u1 dot u2 equal to 0, and is u1 dot u3 equal to 0, and finally is u2 dot u3 equal to 0. So now these are the questions that we should ask. Now this expression simplifies to 1 on root of 12 minus 1 on root of 12, which in turns is equal to 0. So that's u1 and u2 are orthogonal vectors. Now let's verify that of u1 and u3. So now computing u1 dot u3, we are going to have 2 root of 6 multiplying 1 root of 3 plus 1 root of 6 multiplying minus 1 root of 3, then plus minus 1 root of 6 multiplying 1 root of 3. So we are going to have 2 roots of 18 plus minus 1 root of 18 minus 1 root of 18. So we are going to have 2 roots of 18 minus 2 roots of 18, and this is equal to 0. So in this case also u1 and u3 are orthogonal vectors. So it's now left with u2 and u3. So now let's compute u2 dot u3. So we are going to have 0 multiplying 1 root of 3 plus 1 root of 2 multiplying minus 1 root of 3 plus 1 root of 2 multiplying 1 root of 3. So you're going to have 0 minus 1 root of 6 plus 1 root of 6, and this is equal to 0. So in this case also u2 dot u3 is equal to 0. Thus these vectors are orthogonal vectors. So we have the first condition being met and the second condition also being met, which implies that our set is an orthonormal set. Alright guys, thank you for watching. See you in the next video. Bye bye.